Welcome to another physics lesson, and today we are going to look at density of objects. Once again, I implore you to subscribe to this channel. There are many physics content videos on this channel that you can take advantage of. So watch them and drop comments in the comment section. Now, to the topic we have today, density of objects. We want to define density, calculate density, and then we define upthrust. Let us imagine you holding a box, say a paper box, filled with sand. And then you have another paper box of the same dimension, filled with, let's say, cotton wool. That's box 1. This is box 2 of roughly the same dimensions. This is filled with cotton wool, and this is filled with sand. Even though both boxes have the same volume, because they have the same dimension, you will find that they will weigh differently when you try to bring them up. One will be heavier than the other. I'm guessing you are saying that sand will be heavier than cotton wool, and that is true. And why? Why is that? That is because of a concept called density. Density, therefore, in simple terms, is what we define as mass per unit volume. Mass per unit volume. Per unit, it means that for every meter cube volume of a substance, what is the mass? And that is the density. Mass that every meter cube of a substance has. So for example, of the sand and the cotton wool I said earlier, a meter cube of sand has more mass than a meter cube of cotton wool. And that is why sand will have a higher density per unit volume. Going with this statement, we can easily get a formula for it. We can then say that density is mass per. In physics, wherever you see per, it means we are divide, then volume, and that is the formula for density. From here also, we can get the unit of density. It's easy to derive its unit. What's the unit for mass? That is kilogram, kg. For volume, the SI unit is meter cube. So the unit for density, therefore, is kilogram per meter cube, also written as kg m to the power minus 3. In some instances, it may be in gram per cm cube, but the SI units are written in either of these two ways. So let's take a quick example. Let's take the dimensions of the box I gave earlier. So I have the box. Let's say the box has a thickness of, has a breadth, a very small box, 20 cm, and a height of, let's say, 5 cm, and then it has a thickness. I'm doing a one-dimensional drawing here. Let's try and make it a 3D drawing. Good. So, and this goes this way. So it has a thickness. Let's say the thickness here is, let's make it small. Let's say just 2 cm. And you are asked to find the density of the sand. Let's say that the mass of the sand in it, the sand inside, has a mass of 50 kilogram. Now, to find the density, what do you just do? Very simple as you did. Density is mass, 50 over volume. Now, volume, what is the formula for volume? Let's do some rough work here. Volume is length times breadth times height, at least for a rectangular object. So we have the length, the breadth, and the height. Now, do not forget that all of these are in centimeters, and the SI unit is in meters, meter cube. So you must convert all of these to meters. So 5 centimeters in meter will give us 0.05. 20, that will be 0.2. And 2, that will be 0.02. So if you multiply all of this out, let's quickly check what is the answer. 0.05 times 0.02 times 0.2, 0.5 times 0.02 times 0.2. That gives us 0.2 times 0.02. Yeah, that gives us 2 times 10 raised to the power minus 4. 2 times 10 to the power minus 4 meter cube. So you just put that volume here. Now that we know the volume, we know that the volume is 2 times 10 to the power minus 4 meter cube. Now 50 divided by that will give us the density of the sand. That is 250,000 kilogram per meter cube. So that is a simple way to calculate density. Density is very simple. It's a very simple concept. All you need to do is to be able to calculate your volume. You may have a cylindrical object. The volume of a cylindrical object is different. You may have a circular object, a circular plate, volume is different. So get the volume for each and calculate your density. Now the last thing I'll be talking about here is upthrust. Upthrust. Upthrust is simply an apparent loss in weight that an object experiences when it goes into a fluid. So a good example is the swimming pool. Once you get into the swimming pool, if you are conversant with the pool, you feel lighter. It feels like your body is lighter. That's because there is an upthrust acting on you. So we can simply say that upthrust is an apparent loss in weight. Upthrust. And apparent. I say apparent because it's not real. It's not as if your weight is diminishing. It's just because there's something acting on you in the fluid that is making you to feel lighter. An apparent loss in weight by a body in a fluid. And what is the simple way to calculate upthrust? Very simple. You just know that your weight in air, or the weight of whatever the substance is in air, is equal to your weight in fluid, plus the upthrust. Once you are able to take note of this, it's easy to calculate your upthrust. So let's say my weight in air is 500 newtons. And then I get into the pool, and the water in the pool exerts a force of 200 newtons on me, which is my upthrust. So let's say my upthrust is 200 newtons, and I am now looking for what my weight in the fluid is, x. So I just subtract 200 from 500, and that way I have my weight in fluid. So that means that in that fluid, I actually weigh 300 newtons. So in summary, we have been able to define density, calculate density, and we have also looked at what upthrust is. I hope to come to you in a video where I'll be explaining this further, looking at Archimedes' principle and the principle of flotation. Thank you.